Hello, my name is Meher and I'm a staff solutions architect here at DigitalOcean. Let's learn how we can leverage DigitalOcean's GPU droplets and other networking offerings to build scalable, secure GenAI products. Let's take a hypothetical business of an e-commerce company selling shoes. This company might want to appeal to its users based on their geography, let's say. So somebody in India during Diwali, the company might want to choose a certain language and a certain graphic, versus for somebody somebody going to Thanksgiving in the US, they might want to choose a different kind of language and a different kind of graphic. So if you boil down the AI problem in this scenario, which is about personalizing text and personalizing images based on, in this use case, geography. So using this as an anchor use case, let's see how we can use just one single H100 GPU, break it down into multiple instances using something called MIG, and host different GenAI images essentially, and how we can architect a overall solution that will make it easy for us to localize that person and then create or show images or text based on that insight. Let's take a look at examples that we were already able to generate. So this is a pretty interesting prompt that I was able to generate using the LLM and the image itself. So if you see, this is Bangalore, India, with the skyline of the city and Nandi Hills in the background. It's pretty interesting and it's pretty wild as well. So you can imagine, like, this is getting personalized, and this is what could be a starting point for the companies to start using it and start customizing it. In order to do that, we have multiple things to put in place. For example, the GPU droplet that will host the image generation model and the text generation model, and then there's a secure networking layer between that particular droplet and a simple web application service, and all of this is packaged with the Power Global Load Balancer, which will automatically route the end user to the nearest server. We'll come to these aspects in a bit, but what I want to highlight at first is the ability for us to host two fairly complex models, such as Flux.1 image generation model and Llama 3.1 8 billion parameter model on a single H100 GPU using something called MIG. We will look at how to set the GPU droplet up with these two services in a very easy manner. Let's just very quickly look at how you can create your own. Go to your DigitalOcean dashboard, and under the GPU droplets, you will be able to see create GPU droplet. And by clicking on this, select the data center, the OS image, which we recommend AIML because it has the GPU drivers ready, and the type of GPU that you want. Do you want a single H100 or do you want a box or H100 by 8? And then click on create droplet. I've already created mine, so let me just quickly go to that. While I set up this console, let's also take a brief look at what MIG is all about. MIG is a technology provided by NVIDIA on certain GPU architectures, H100 being one of it. You can essentially break down that single GPU into 7 independent instances. The independent instances have their own resources, which is memory, cache, and compute, which also guarantees quality of service. Thereby, the workloads running on one instance do not affect the workloads running on the other instance. So this is pretty cool. And in order to do that, we'll have to run a few commands. This is my web console of the GPU instance that I'm running. You can see that this droplet has H100 attached to it, and currently there are nothing running on this. In order to enable MIG, you'll have to run a few commands. This is NVIDIA the GPU ID, and to enable MIG, you just need to press 1. As I said before, NVIDIA allows you to break down a single GPU into 7 instances, but in our case, I want to use only, say, 2 instances of 40 GB each. And I will be able to do that by using this profile 9 and create 2 MIG instances with that profile. And this is how you create that. All it's doing is NVIDIA MIG, create a GPU instance of these 2 profile types, -C for create. As you can see, it's already created, and let's take a look at how our NVIDIA SMI looks like now. If you can see, there's a new section called MIG devices that's got added with 0 and 1 IDs, and then you can see that it is about 40 gigs each. There's also another important command that we need to know, which is how do I access this particular MIG instance? And this UUID is something that we will have to use pretty soon. Just copy this for now. So if you recall, what we're trying to do is to set up 2 models. One is an image generation model and one is a text generation model on the single GPU, which is currently what you can see. And each one will be placed on one MIG instance, and that's why I will be needing these IDs. So coming to setting up the Flux model, I'm using a particular repo called OpenDI Images Flux, which is a pretty useful repo that I found. It has the Flux.1 model dockerized already, so that we can just directly pull the Docker image and then run it without worrying about installing each package and each requirement specifically. So I've just cloned the repo to create a config JSON. I need to copy into the config folder and run this command. I'm just copying my Hugging Face token, the MIG ID here. I will walk through what this command is doing in a bit. So if you see, essentially this command is just running a Docker instance with a few environment variables, an NVIDIA runtime, a port number, a bunch of volumes associated, and a particular image. Let's see what happens if I run this. Yes. I'm just going to list the logs. Yeah. It says that the application is running on 5005. I have my post one. Let me just quickly see if I'm able to generate an image. So if you see, I have the IP address, the port number, and an image generation. Yeah. The first call is going to take a little bit of time because it's going to download the model if the model already doesn't exist. But once the model is downloaded, we don't need to worry too much. It's just going to generate the image pretty quickly. While this is getting set up, let's also start our text generation model. So the LLM itself, we are using VLLM, which is also a pretty popular way of hosting large language models on your own instances. And the command that we're going to run is also pretty similar. It's just a Docker run command with a runtime of NVIDIA, the MIG instances as environment variable, the Hugging Face token, similar to what we have here, and the Docker image changes with the model that you want to load. So let's just replace this here as well. I will have to check the second MIG ID. Yep, this looks good to me. Let's see what here. So you can see there is the application running on 8000, which is great. Let's see if this is also, let me just trigger the model. Have another request for this, and as you can see, it's already returned the response. If you see, the query that I'm making is basically to generate 5 prompts for the city of Hyderabad, and then in a JSON manner, and then it did respond with something. So it's great. So you know the LLM is working. Let's just wait for a few more seconds to see if the image generation is also working. So as you can see, it downloaded a bunch of stuff and it generated a new image. So let me just rerun, just for sanity's sake. We'll just rerun the query, and boom, it's already done. In a matter of few seconds, it's basically loading the base64 text, which is slightly big. So the image itself comes in a base64 manner. You can directly use this as a URL, but I typically like to do it in a decoder. Let's see what kind of an image it generated for us. Well, it spoiled the name, but I think it's fine. Yeah. So moving on back to the next steps. With this, you can see that we have set up MIG. We have set up 2 services on the single GPU, and we are able to hit and generate text and hit and generate images as well. Coming back to the overall problem. So in this next step, let's look at the simple application that we've built to demonstrate the entire problem. So this is the URL that I've had. This is the web application that I've built, which basically refers to a single droplet here. And if you see, I am currently in Naubat Pahar in India. And the server, it is saying that the server that connected itself is to United Kingdom. These are the prompts of the place where I am. A panoramic shot of the Pahar in Ranchi, with the city skyline visible in the distance. It's pretty interesting. These prompts and this image is getting generated by the GPU that we just enabled. This is the application that we've built overall, and that is what is represented in this container. As you can see, we have hosted this droplet in 3 different regions. One is in Sydney, one is in New York, and one is in London. In the next steps, what we will do is to basically create a new droplet with that application web app in Singapore and connect it similarly to this entire architecture. Now, one question that is logical, at least for me, is how do we know that this particular server is connecting to the GPU using the private network, right? So what I have done is in the code of the application, I am using the private IP and not the public IP. So private IP is obviously only going to be visible inside a network, and if it works, it only works when there is a private network connection between the server, which is the application, which I'm going to host on Singapore, and in the Toronto's GPU. This is a very simple application, so I'm going to use a very simple droplet. I'm going to leave the defaults as it is. I think the custom image is the only thing that I will change. So this I'll just change to the snapshot that I have created. I know that this is the snapshot running the latest version of the application. So I'm just going to hit create droplet. While this is spinning up, we can look at our networking. Currently, there is a load balancer, and you can also see that there is a VPC peering all the existing VPC networks, right? So by default, DigitalOcean resources are created in a particular region's default VPC, which is provided out of the box. What we can do is to create a peering connection between 2 different VPC region. So if I want my Toronto resources to communicate with New York resources, I just need to add, or let's take Singapore example because Singapore is anyway coming up. Yeah, Singapore has 0 peering connections, right? So what I can do is I can create a peering connection between Singapore and Toronto, which is where my GPU droplet is, and create a peering required connection. And this way, there's one more step, and I will show you in a bit once the droplet is ready. But this way, at least the GPU can potentially talk to the droplet in Singapore region. And the other step that I know that I have to do is to restart the network D on Singapore. So let's just go to Singapore, go to the console and run one command, which system ctl network D, restart network D. Now, so whenever we do VPC peering, we just need to restart the network D in that droplet. By default, there's no Docker running. And all I need to do is to basically run this command, which is I am basically pulling a custom image v3, and I am pulling that, and all I'm going to do is run that Docker image, verify whether everything is working as expected. But just go here. So this is the IP address of Singapore. So hopefully it should say the server location is Singapore. So that's great. So everything seems to be working fine. And if I'm able to get the prompts, that also means that the connection between this region and Toronto is established, and we are able to generate the prompts and the images as well. Now, we have added a droplet and we have tested that this droplet is working fine. But as you have seen before, my GLB is pointed to this domain, and this domain is still routing to UK because it still thinks UK is the nearest droplet for me. Rightfully so, because it doesn't know about Singapore yet. So all we have done is added a Singapore droplet here and paired it with GPU droplet. We have not added this to the GLB. So let's go and fix that right away. And I'll show you how easy that is. Let's go back to networking. Let's go to load balancers, existing load balancers. Let's see if I can add a droplet here. All I need to do is Singapore 1. Take that one is off. So in a matter of a few seconds, you have added another droplet. And as you can see, it did get added and the health looks good. So now when we go to the domain name and try to detect the location, it should change from, the server location should change from UK to Singapore, because Singapore is clearly the nearer server. So, and it also goes to the GPU, generates the prompts. Voila. And let's see what kind of image do we get with this prompt. Amazing. Beautiful looking image. So this should conclude the overall presentation, and hopefully you get a starting point of how you can build globally scalable, fairly secure GenAI products using the Droplet GPUs and global load balancing and VPC peering. Thank you so much.